Hi everyone, this is the first video for chapter 6. 6A is pretty quick and easy, so I'm going to try to do 6A and 6B in this video, although I should never really overcommit, but I just looked at 6A. It doesn't look too long. It's just converting between degrees and radian. Not that this is really a big part of the course at all, but it's probably good to think about the relationship between degrees and radians, just because up until probably you did methods last year, you were just working in degrees. Now in methods this year and last year, if you're doing any trig, you do it in radians most of the time. So always make sure your calculator is in radian mode. And if you do further maths, although I don't think you guys do geometry and measurement, but if you do, you're working in degree mode. So doing methods, we're just working in radian mode. So with your calculator, make sure it's in radian mode. So with your calculator, you can see the DEG, which stands for degree. You can just press on that and change it to radian mode quite easily. All right, so if you're wondering what it means by unit circle, that just means we have a circle with a radius of 1. All right, so yeah, that's pretty much what you can see here on your unit circle, a very, very basic circle. You've got, it's a bit hard to see. Let me just grab my pen. Sorry, I'm pointing, but I don't think you can see my pointer. So you can see here we've got 1. Okay, so a radius of 1. So the distance between the center and the outside of the circle is 1 for a unit circle. All right, so in 6A, we're just looking at converting degrees to radians or from radians to degrees. So you can see in this pink box, we've got our conversion here. So in question 1, we're going from degrees to radians. So we need to multiply by pi on 180. So very, very easy stuff. So let's just do a few because I don't want to spend too much time on this. Now, if you want to make this easier, this is the same as 50 pi on 180. Just cancel your zeros out and see if you can simplify it. We can't, so 5 pi on 18. Now, if you were to do that on your calculator, yeah, just type in 5 pi over 18. Oh, but it says in terms of pi. So let's just leave it as 5 pi over 18. All right, question B, 136 times pi on 180. All right, so here we do need to think about, well, what's the highest common factor? Oh gosh, I know they can, 2 goes into both of them, so let's just halve them both, and that's going to be 90. 136 divided by 2, what's that? 68. All right, so we can halve again. 34 pi on 45, and we can't simplify any further. So question 1 and probably question 2 as well, you really need an understanding of fractions. All right, so how to simplify fractions. You can do this quite easily on your calculator. But it does say to leave your answer in pi. So remember, in methods, we tend to write our answers as exact values. So unless it says to a certain number of decimal places, you always, with trig, put your answer as an exact value, and it usually involves pi. But if it doesn't, just put it as a fraction or whatever the exact value is. If you find yourself rounding a decimal, that is not the exact value. Okay, so if you want an exact value, you either have terminating decimals like 0.5, or you have a fraction like a half, or you might have your answer in terms of pi like this. All right, so I'm going to move on to the next question because we don't really need to spend too much time doing that. It's just simple conversion. All right, so for question 2, we're doing the other way around. So this time, we've got radians and we're putting it into degrees. So if I just go back up to our little pink box, radians to degrees, we're multiplying by 100 over pi, 180 over pi. So just the reciprocal of 4. All right, so I'm going to write that here. So times 180 over pi. All right, so question A, we got pi on 3 times 180 on pi. And you'll notice what is actually happening here because we don't tend to have degrees in terms of pi. Your pi's actually cancel each other out and we're left with 180 over 3, which is 60. So 60 degrees. What else have we got? 5 pi on 6 times 180 over pi. All right, so those pi's cancel out. Now, this is where you've got to understand fractions. So we've got 5 over 6 times 180. You can actually switch your numerators. So we can say, all right, 180 over 6 times 5. All right, so 180 divided by 6 is 30 times 5 gives you 150 degrees. You'll notice when we write radian, we don't actually put the symbol for radian, but when we do degrees, we do put the symbol for degrees on there. All right, let's do one more. So 4 pi on 3 times 180 over pi. So our pi's cancel. Now, I'm just going to switch the numerators. So the 4 and the 180 are going to switch. So I'm going to make that 180 over 3 times 4. So that's going to be 60 times 4, which is 240 degrees. All right, and if you like, you can go and do the rest of those questions and just check your answers in the textbook. All right, let's move on to 6b. So defining circular functions, sine, cosine, and tangent. All right, so the easiest way to explain what sine, cosine, and tangent are and how they relate to your unit circle is just to use a right angle triangle. Okay, so we all hopefully are familiar with SOHCAHTOA, okay, which is what we've basically got here. All right, so you've done these trig ratios since year 9. So SOHCAHTOA. You can use this triangle to help you remember exact values, and I might talk about that a little bit later. But your understanding of this will help you understand the unit circle a little bit better. All right, so we're only going to focus on sine and cos for now, not necessarily tan. So if I just scroll along. All right, so you can see here, this triangle has been put inside our unit circle. So I'm just going to redraw that here. All right, so there's theta. It's a right angle triangle. Remember what I said before, in a unit circle, the radius is 1, or your basic unit circle. Now, this is also drawn on a Cartesian plane. So if you think of your set of axes, so we've got x and we've got y. So the height of this triangle is y, all right? So it corresponds to this y coordinate. And then the distance here is x and corresponds to this coordinate here, all right? So if we're looking at sine theta, that is given to you by your trig ratios, opposite over hypotenuse. So we want the opposite side over the hypotenuse. So y over 1, your opposite side is the side opposite your angle, so that's y over 1, and that's y, and it's already written down here, but I'm just rewriting it so you know what I'm talking about. And cos theta is adjacent over a hypotenuse, so x over 1 equals x. So when we look at, and then tan theta is opposite over adjacent, so we've got y over x, or sine over cos, which is important to remember. Actually, I might just write that here. Tan theta is the same as sine theta over cos theta, because when we do our exact values, you might use this relationship to remember what tan is equal to. All right, so moving along, let's just forget about, okay, actually we'll talk about this. Sorry, if you really need to go back to the basics of the unit circle, you need to watch my previous videos where I've talked about it in a lot more detail. So this video is kind of assuming you've got a little bit of background. With your unit circle, we always start here. Oh God, what am I doing? Sorry, let's just get rid of that. I was all ready to highlight. Now I want to Okay, so we always start here at 0 and we go in an anti-clockwise direction. Now, you've got 4 quadrants. Okay, so on your Cartesian plane, you've got 4 quadrants. So we read them as quadrant 1, quadrant 2, quadrant 3, quadrant 4, okay, because we're going around in an anti-clockwise direction. All right, so that's important to remember. Now, in quadrant 1, quadrant 2, quadrant 3, and quadrant 4, sine, cos, and tan are either negative or positive, depending on which quadrant you're in, okay, and I think that's what we're going to go into in the next one. All right, so the signs of circular functions. So in your first quadrant, all are positive, all right? And the reason for that is because, remember, we've got a value in here. So x, y, remember, is cos, sine, okay? And cos is equal to x, sine is equal to y, and in this quadrant, they're both positive, all right? Positive, positive. And you should know that from when we did linear graphs back in year 9. Quadrant 2, though, our x coordinate is positive, but our y, whoops, no, other way around. Sorry, let's just quickly erase that. Our x is negative and our y is positive, okay? Because we're in the negative part of the x-axis, but we're still above the x-axis, still in the positive y. So if we think about the points as being x, y, we've actually got negative x. All right, so in quadrant 2, cos is negative. Oh, where am I going to write this? Negative cos and positive sine. All right, so if you had an angle between 90 and 180 degrees, or pi on 2 to pi, if you were in radians, your cos would be negative and sine would be positive. In quadrant 3, both your x and your y are negative. So we've got negative cos and negative sine. This is all written later, so if you're trying to make sense of it, I've got a better diagram coming up. And then in quadrant 4, x is positive, y is negative. So cos is positive and sine, oops, is negative. No, I've got that negative sign. Now remember, tan is equal to sine over cos. All right, so when you're dividing a positive by a positive, you get a positive. So tan in quadrant 1 is positive. That's why all are positive in quadrant 1. For quadrant 2, you've got positive sine over negative cos. So tan is negative, so negative tan. All right, remember this is there's a better diagram coming up, so don't worry about trying to squeeze all this in like I am. So the only trig ratio that is positive is sine, or the only function that is positive, sine. All right, in quadrant 3, both cos and sine are negative, but remember tan theta is equal to sine theta over cos theta. So because they're both negative in quadrant 3, a negative divided by a negative gives you a positive. So in quadrant 3, tan is actually positive. So that's why we've got T there. And then in quadrant 4, we have negative sine over positive cos. So the only one that is positive in quadrant 4 is cos. Now you do need to remember that. So you can come up with a way of remembering the letters. I always say acts, the word acts, but you're doing that in a clockwise direction. Yeah, I can't remember what I used to do it when I did it in high school, but I remember we did have maybe a little cheeky one. I can't remember what it was, but I'm sure you've probably been told one to remember ASTC, and you go in an anti-clockwise direction. All right, so what we just talked about is rewritten here. Okay, the only thing that isn't written here is the tan. Okay, so quadrant 1, you can see cos and sine are both positive. Quadrant 2, cos is negative, sine is positive. Quadrant 3, sine is negative and cos is negative, and then quadrant 4, cos is positive, sine is negative. All right, so if you wanted to rewrite tan in there, you can, but just remember tan is equal to sine over cos. All right, take a breath. Okay, so your reference angle, we always go from the horizontal. Okay, so you can see in these three diagrams, we're going from the horizontal, from the x-axis. So if we're in, and these are in degrees, but I probably should also write them in radian. Okay, so if we're going from, let me just think, 90, well, this is 0, and this is 90, and this is 180. Okay, so it doesn't, oh, I suppose it only has, all right, if we're between 90 to 180, which is the same as in radians, pi on 2 to pi. So this is pi on 2 to pi over here. We always do 180 minus theta or pi minus theta. So you can see we always go from the horizontal, not from the vertical. So we either do 0 plus or 180 minus, depending on which quadrant we're in. If we're, so that is, doesn't say, we'll put quadrant 1 here. Oops, no, not quadrant 1, quadrant 2. This one here, we're looking at quadrant 3. All right, so remember we go from the horizontal. So in this one, because we go around the unit circle in a anti-clockwise direction, okay, so we're going from 180 to 270 this time. So pi to 2 pi on, oh my gosh, I just had a blank. No, 3 pi on 4. No, 3. Oh, I've forgotten just briefly. Sorry. Let me just think. 3 pi on 2. All right, sorry, I just had a little blank. So it is 3 pi on 2. And this one is pi. Okay, so if we're going from pi to 3 pi on 2. Okay, so the same as 180 to 270. We do the angle minus 180, or you can just, sorry, I'm just got to focus. Okay, so pi minus 180 will give you just this angle in here, and we use that for our reference angle. So I'll talk about that in a second. Then if we're in quadrant 4, all right, so from 270 to 360, so this is from 3 pi on 2 to 2 pi. Okay, we do 360 minus theta. So we always need to work with what we call our reference angle. So our reference angle is an angle between 0 and 90. So that's why we've got this little triangle written in here. So this angle here is what we call our reference angle. And it just depends which quadrant we're in as to whether it's negative or positive. So when we do some questions, it'll probably make a little bit more sense. It's hard to explain briefly without going into too much detail. This little box here, we've got multiples of 90s. So remember that for your unit circle, we have a radius of 1. Oops. That's why we've got 0, 1, 0, negative 1. Okay, so as we move around the unit circle, so if I just go a unit circle like this. Okay, so if we're starting at this point here, that is the point, if we're doing a set of coordinates, 1, 0. So remember our coordinates x, y are cos, sine. So at this point here, cos is 1, which we've got written here, and sine is 0, our y coordinate. If you were to graph them, and you might be familiar with what sine and cosine graphs look like, your sine graph always starts at 0, or your basic sine graph, and goes up and then down. Okay, so that's basically what it's doing for 1/2 of the circle, and then the other half of the circle. So here we are at pi, so you can see it's positive. we are below. And then we get to 2 pi. All right, so that's your sine. Let's call that sine x. So when we move to here, our point is now 0, 1. So at 90 degrees, cos is 0, sine is 1. So here you would have 1, and here is -1. And then you just continue around the circle. So at this point here, we are at -1, 0. So cos is -1 and sine is 0 at 180 degrees or pi. And then down the bottom, this point here, we're at 0, -1. So at 270 degrees, cos is 0, sine is -1. And then we get back to the start. So 0 and 360 are the same, okay, just here. All right, so I'm just going to also sketch this cos graph, even though we're not really doing any graphing here, but sometimes I think it's easier to understand what is happening in this unit circle if we actually graph it. So cos graph starts at 1 at 90 degrees or pi on 2, it's at 0. And then it goes down to 1 at pi, sorry, -1, and it goes up and it goes back up there. Okay, so when we look at sine and cosine graphs, we'll look at that a bit more. And you do have amplitude and period that do change your graphs. So you're not always going to have what we call an amplitude of 1. All right, so it can be stretched or dilated as well, and then it can also shift. All right. Now, exact values. So you do need to know your exact values. You don't have to learn how they relate to degrees. You just have to remember your exact values. Okay, so that's for, if I just scroll down here, basically you need to remember this table here. All right, and I'll explain an easy way to remember it, or one way of remembering it is drawing these two triangles. So these triangles, some students prefer to draw these and then think of SOHCAHTOA, and then they can write down these values here. What you can see here is, like, let's take sine of 45. Okay, so we have sine theta equals opposite over adjacent. So your opposite side is 1 and your, not opposite over adjacent, opposite over hypotenuse. So your opposite side is 1, your hypotenuse is √2. So that's where you get 1 over √2, but we don't tend to leave a square root in the denominator. So we have to rationalize the denominator. So that's why we end up with √2 on 2. Okay, so it's the same thing. We just don't tend to leave our square root in the denominator. Okay, so you can choose to remember those two triangles. Now, if you were doing, if you wanted just to remember this table, it's actually not that difficult to remember. And I think in one of my videos, I'm pretty sure I do, go through how to remember it. So as long as you've got your order correct, okay, so degrees, you can do them as well. So we're going up 30, 45, 60, 90. So they're your main ones. How they relate to radians. So we've got 0 is the same as 0 radian. 30 degrees is pi on 6. Okay, so that's, if we were converting that, it would be pi times, actually I can't remember. I can't remember how to convert. Oh my God, my brain has gone blank. Okay, so you can just use this conversion up here. Where are we? Back in 9a. All right, so if we're going from degrees to radians, multiply by pi on 180. All right, let's scroll back down. But as I said, you don't really need to remember degrees so much. So we've got 0 radian, pi on 6 radian, pi on 4 radian, pi on 3 radian, pi on 2 radian. Okay, so as long as you can remember that, 6, 4, 3, 2. Now, for these values, we are, you don't have to do it for all of them because you might remember 0 and 90, but just, we're going to do a fraction for all of them. So we're just going to draw the vinculum, the line for the fraction. And then on our numerator, we just go 0, 1, 2, 3, 4. And then for each of them, we have a denominator, which is 2. So 2, 2, 2, 2, 2. And you can take the square root of all the numerators. So square root, square root, square root, square root, and the square root. Now, I don't have much space on here, so I'm going to do it in a different color. All right, so root 0 on 2 is 0. And you'll probably remember that 0. Root 1 on 2 is a half. Root 2 on 2 is what we wanted. So root 2 on 2, that one can't simplify. Root 3 on 2, that one doesn't simplify. Root 4 on 2 is the same as 2 on 2, which is equal to 1. Okay, so you can remember it that way. It does sound, now that I go through it, a lot more complicated than what it needs to be, but you will probably remember them. Okay, you really need to remember them. But if you do have a little bit of trouble remembering, you just go sine, and that's your order. Now, cos is the opposite. Okay, so if we look at cos, all right, you can see it just goes in the opposite direction. So once you've done sine, you can do cos. So we've got 0 up here, so 0 down here. Half, half. Then we've got root 2 on 2, it's the same for both. Then root 3 on 2. And then down the bottom, we had 2 on 2, which is 1. Okay, so as long as you can just do one sine, you can do cos because it's the opposite. And then tan theta, remember, is sine over cos. So we're just going 0 over 1 is 0. A half over half divided by, what is that, root 3 on 2. That's the same as a half times 2 on root 3. They cancel out and we get 1 on root 3. If we're rationalizing the denominator, you multiply it by root 3 on 3. Sorry, root 3 on root 3. So we get root 3 on 3. Root 2 on 2 over root 2 on 2 is 1. Then for the next one, root 3 on 2 divided by half is just the reciprocal. Okay, so they're the reciprocal. And then the last one, you're going to be dividing by 0. That's why it's undefined. Okay, so you either remember these triangles, these two triangles, or this table. Okay, I would strongly encourage you whenever you're doing any assessment with Trig that you write these out. All right, or as soon as you need them, write them all out. Okay, don't just try to remember, like, if you had cos 60, you might think, oh, what is cos 60? Sometimes it's easier just to write the whole thing out and follow that pattern that I went through. If you just want to use these triangles, okay, they're probably a little bit easier if you were to do cos 60. So you do what works for you. Either use the triangles or use these table of exact values. All right, let's do some questions from 6B. All right, so we need to evaluate all of these, and I always like to have a unit circle to refer to. So I'm just going to quickly draw on, and oh gosh, terrible one. But you should always do a unit circle. All right, if you're having to calculate anything, just drawing a unit circle will take you like 20 seconds. All right, so we've got 0 and pi, then half of pi is pi on 2, and then 3 pi on 2. And then we're at 2 pi. All right, so for the first one, let's do as many as we can. We seem to always do the easier ones. So sine of 3 pi. Oops. Okay, so we've got to find 3 pi first of all. So if I always start at 0, and we go around 1 pi, 2 pi, 3 pi, so I'm here. Okay, when I'm here, sine remember our coordinates, x, y, cos, sine. Sine is your y coordinate. So at this point here, it is -1, 0. So sine of 3 pi is equal to 0. All right, for question B, we've got cos -5 pi on 2. Don't worry about that negative just yet. So let's just focus on 5 pi on 2. So remember your, oh my God, I just had a little blank. So each 90 degrees is pi on 2. So this is effectively, we're going to be either at 3 pi on 2 or pi on 2. So let's go around the unit circle. Okay, so we were to go all the way around, and of course my pen's not working. Okay, so if we were to go all around our unit circle, okay, we are at 4 pi on 2. Okay, so 2 pi is the same as 4 pi on 2. So if we go just a little bit more, we're at 5 pi on 2. Now remember at this spot here, okay, we are on the y-axis. So x is equal to 0 and y is equal to 1. Now with our exact value, because we're cos, remember cos is your x coordinate, that is equal to 0. Okay, so even though we don't have these reference angles that we did earlier here, you still need to use your unit circle to calculate these values. All right, I'm just going to pause and rub out what I've got there. All right, so let's do question C. So we've got sine 7 pi on 2. All right, so we've got to find 7 pi on 2. So we went all the way around. We're at 4 pi on 2. And then we've got to go another 3 pi on 2. So we're going around and we're here. So at this point here, we are at 0, -1. We're doing sine. Let me just get my pen. Okay, so sine is your y coordinate, so that's going to be -1. All right, I'm just wondering if there's any harder one with reference angles. There aren't, so cos 3 pi. All right, let's just try to move a little bit quicker through some of them. So sine -4 pi. All right. Let's get rid of that scribble on there. Okay, so let's do D, cos of 3 pi. So we've already done 3 pi before. Remember 3 pi was here. Okay, and at this point we're reading off the x coordinate because cos is your x coordinate, so that's going to be -1. 4 pi is, so we're going around once it's 2 pi, around twice it's 4 pi, and sine is your y coordinate, so that is 0. All right, let's just have a look. Oh, let's do a tan. So f just do a few more. So tan of -pi g, whoops, sorry, tan of 2 pi, and we'll do h, tan of -2 pi. All right, so these are just looking at 0, 1, or -1. Okay, we're not really doing any reference angles here. Okay, so -pi. All right, so it's the same as at pi, so we're just kind of still making our way here. At this spot, remember tan is equal to sine over cos. So our sine is 0 and our cos is -1. So it's going to be 0. All right, so we're just reading off the coordinates, and I already had the coordinates there, -1, 0. So cos is -1, sine is 0, so 0 over -1 is 0. 2 pi, we are now here. So the coordinates at that point are 1, 0. So we've got sine over cos, so 0 over 1. And that is equal to 0. And tan of -2 pi, we're at the same spot, so that is also going to be equal to 0. So basically for this question 1, you're either at pi on 2, 3 pi on 2, pi or 0. Okay, so out of the 4 points here, you need to decide where you are and what the x coordinate is and what the y coordinate is. So I've already written it for the other 2 points. I'll do it here. So this is 0, 1. And up down here we have 0, -1. Okay, so you just need to know. So if you wanted to keep going for I, j, and k, just where you are on the unit circle. Just looking at I, first of all, so 23 pi, because it is an odd value, so 23 being odd, you are going to be here, all right? Whereas if you were even, you would be on the other side. Cos 49 pi on 2, so you're going to be up here at pi on 2, and then cos 35 pi, you're going to be back here at pi. All right, so you don't have to go around the circle over and over again. You'll see a pattern and you'll be able to do I, j, and k. All right, question 3, we're going to be doing the reference, using the reference angles to figure out what our exact values are. All right, so we're going to draw the unit circle again. Just a very rough sketch, a much better circle. All right, so we're at 0, pi on 2, pi, 3 pi on 2, and then 2 pi. Okay, so cos 3 pi on 4. So always, actually, let me just rewrite it here. So sine 3 pi on 4. When we forget about the pi part for now, when we think about that, that's the same as 3/4, which is the same as 1 minus 1/4. So it does help you do your exact values if you think of it as pi or 1 pi minus pi on 4. So we are effectively in this quadrant here. So this angle here is pi on 4. Which is the reference angle here, pi on 4. All right, so we don't have to write that reference angle. The pi on 4 is the important thing. All right, so this part is important. All right, that's our reference angle. It's also important that we note which quadrant we are in. So we're in quadrant 2. So remember, in quadrant 1, they're all positive. In quadrant 2, only sine, quadrant 3 only tan, and in quadrant 4 only cos. So because we're doing sine, our answer is going to be positive because we're in the second quadrant. Now pi on 4, if you can remember your exact values, fantastic. I think it's √2 on 2, but my memory is terrible. No, yes it is, √2 on 2. So let's go down, oh, too far down. So your answer is √2 on 2. All right, you only need that reference angle. And that's because, like I drew before, but I might draw again here, your sine graph continues. All right, so here's your sine graph, and because there's a pattern there, we only really have to worry about this reference angle, okay, because it's going to be the same as 3 pi on 4. All right, let's move on to question B. So this time we've got cos 2 pi on 3. So again, think of that as 1 whole pi minus pi on 3. So pi on 3 is our reference angle. So we go, I might just highlight it. Okay, so that's our reference angle. We're in the second quadrant. All right, so if I draw on the second quadrant, it's going to get too messy, but we're in the second quadrant where cos is negative. So our answer has to be negative. So we've got to find out what pi on 3 is. So we can scroll up to here. Cos pi on 3 is a half. So your answer is negative half. All right, so let's keep going. So question C, we have cos of 7 pi on 6. Now this one, we are over one whole. So 7 over 6 is the same as 1 and 1/6. So we're going to have pi plus pi on 6. So this time we are in this quadrant, the third quadrant, all right? And cos is still negative there, okay? Cos is only positive in the fourth quadrant. So our answer has to be negative. Our reference angle is pi on 6. All right, so pi on 6. So we go back to our, what do we call it? Table. Cos pi on 6, root 3 on 2. So you need to remember these reference angles. Okay, so with extra practice, you'll remember them. So negative root 3 on 2. All right, let's move on to, I'm just trying to see if there's a bit of a harder one there. No, let's just do D. Sine 5 pi on 6. So we are not quite at 1, so it's pi minus pi on 6. Now we are in a second quadrant, so it's going to be positive. Now pi on 6, do I need to scroll up? I think I do. I think it's a half from memory. Let's just check. Yes, so it's a half. So positive half because we're in the second quadrant. All right, question E. We've got cos 4 pi on 3. So that's the same as cos, pi plus pi on 3. So pi on 3 being our reference angle. Now, we did pi on 3 earlier, so I know it's going to be a half. Let's just check which quadrant we're in. We are in the third quadrant, so cos is still negative. So it's going to be negative a half. We've got F, sine 7 pi on 4. All right, so this one here, we are nearly at 2 pi. So if we were doing 8 pi on 4, that would be 2 pi. So sine is 2 pi minus pi on 4. All right, so our reference angle is pi on 4, which is root 2 on 2. And we just got to check which quadrant we're in. So we're doing 2 pi minus pi on 4. So we're in the fourth quadrant, so it is negative. And then lastly, oh, not lastly. Oh, did I miss one? Oh, sorry. I did. Let's just switch them around. F and G around the wrong way. 5 pi on 4. So this is the same as sine pi plus pi on 4. So pi on 4 I know is root 2 on 2 because we just did it before. And we just got to decide whether it's positive or negative. So pi plus pi on 4, you're in the third quadrant. So it's going to be negative. And then our very last question, cos of 5 pi on 3, which is the same as 2 pi minus pi on 3. So pi on 3 we've done before, so I don't need to scroll up, which is a half. And we've just got to decide which quadrant we're in. So it's 2 pi minus, so we're in the fourth quadrant. So it's just positive a half. And I think that's it for 6B. Awesome. Long video, girls, but good to go over. All right, bye.